Hello, I am Srikanta Mishra. Thank you for joining me on this brief tour of the Rosen Associates virtual course on applied statistical modeling and big data analytics. This virtual course is being presented as a distance learning offering over 4 days, with each session lasting 4 hours. The course provides a programming-free and hands-on introduction to the topics of statistical modeling and big data analytics for petroleum engineering and geoscience applications. The highlights of the course are easy to understand descriptions of the common techniques, case studies demonstrating the applicability and limitations, and hands-on problem sessions using open source software in a programming-free environment. So let's begin with some definitions. Statistics is a useful tool for describing data and converting it into information that we can act upon. This involves collecting and summarizing the data so that it can be interpreted in terms of the structure, trends, and relationships between the input and the output variables. Next, big data. Today's datasets are characterized by the 3 V's, that is volume, variety, and velocity. We have to deal with large volumes, millions of records, and hundreds to thousands of variables, multiple varieties, text, numbers, images, and video, and high velocity because of rapid downhole sampling. What about data analytics? This helps us examine the data, understand what the data says by going through a learning process which leads to a predictive model, and using this model to make predictions which hopefully leads us to better decisions. So we can summarize by saying that data analytics is a process that helps understand hidden patterns and relationships in large, complex datasets. Basically, we are trying to build data-driven models as opposed to physics-based models. As it turns out, there are several areas of application relevant to E&P problems that have emerged or are emerging over the last several years. For example, in exploration, the goal has been to find hidden patterns in large geologic datasets. In reservoir management, the objective could be to identify factors that lead to improved performance either at the well scale or at the field scale. In proxy modeling, the objective might be to create fast system emulators or surrogate models from the output of physics-based models. In performance forecasting, the goal could be to make real-time predictions of system response. This could be drilling or fluid injection. In predictive maintenance, the objective may be to combine streaming data with past performance to predict potential failures. So, building upon these ideas, the course content is as follows. In session 1, we will take a look at foundational concepts in probability and statistics, along with basic regression analysis and multivariate statistical concepts such as principal component analysis and clustering. In session 2, we will begin with some basics of machine learning and then follow that with details about the tree-based modeling methods such as regression and classification trees, random forest, and gradient boosting machines. In session 3, we will look at non-tree based methods such as neural networks and support vector machine, and we will supplement this with case studies as well as hands-on problem-solving sessions, which will be a common feature for both session 2 and session 3. So finally, in session 4, we will quickly take a look at some other topics related, such as experimental design and response surface analysis and uncertainty quantification, before doing a wrap-up and then pointing the students towards the useful resources in this particular subject of study. So essentially, my goal in this course is to provide you with an expanded repertoire to analyze data and build data-driven models using both conventional statistics and machine learning. As I mentioned earlier, the tools of the trade include exploratory data analysis, basic regression modeling, multivariate statistics, machine learning for regression and classification, experimental design and response surface analysis, and finally, uncertainty quantification. So to conclude, here is a brief summary of my background. I'm currently a senior research leader for energy and the discipline lead for oil and gas reservoir sciences and data analytics at Battelle Memorial Institute in Columbus, Ohio. I develop and manage a portfolio on computational modeling and data analytics for a variety of subsurface resource management projects. I am the author of the book Applied Statistical Modeling and Data Analytics, which will be used as a textbook for this course. The book was written in collaboration with Professor Akhil Dattagupta of Texas A&M University. It was really a book by petroleum engineers for practitioners in petroleum engineering and geoscience. In 2018-19, I had the honor of being an SPE Distinguished Lecturer on the topic of Big Data Analytics. What can it do for petroleum engineers and geoscientists? I'm also a short course instructor in petroleum data analytics at various conferences and also for individual companies. For the last several years, I've been a member of the ERTech program committee focusing on sessions related to data analytics and machine learning. And I currently serve on the scientific advisory board for a machine learning initiative organized by the Department of Energy's National Energy Technology Lab in Pittsburgh that involves a number of national labs here in the US and also many leading universities. In terms of academic background, I'm a petroleum reservoir engineer with a long-standing interest and background in statistics and data analytics, and you will see that combination come through during this course. So with that, thank you for your interest. I hope to see you soon in one of my courses.